Hello. In this short video, we're going to talk about parametric equations. Remember, in previous video, we defined x as a function of time. We defined y as a function of time. And we said a pair of equation with the graph of it is called a plane curve. Therefore, this is a plane curve. And this plane curve, it is possible that somebody asks you if this is a path of the ball that the quarterback throw to the receiver. It's not a perfect path, but I tried. Well, what is the velocity of the ball here? What is the velocity of the ball here? What is the velocity of the ball here? And what is the velocity right here? Oh, at that point, the velocity is 0. And what happened at that point? What is my concavity? When the path is concave down, when the path is concave up. And even though if I give you the velocity, sometimes you ask me, what is my acceleration? Because acceleration is the derivative of the velocity with respect to time. Therefore, I want to know if I can apply the notion of calculus, derivative of integration, into that pair of equation. First, I'm going to have a plane curve. And my plane curve, in my head, I think of maybe negative x squared plus 2x plus a 1. Then here, I'm going to break it to a pair of parametric equation. And I make my x of t equal to 2t plus a 1. And my y of t is equal to negative 2t plus 1 squared plus 2 times 2t plus 1 plus a 1, and that becomes 4t squared plus 4t plus a 1, and when I apply by negative, it becomes negative 4t squared minus a 4t minus a 1, and that's the plus 4t, and that becomes a plus 2 and a plus 1. Therefore, that 4t and 4t is cancelled out. And that becomes negative 4t squared minus 1 and plus 1 is plus 2. Therefore, this is my y of t, and this is my x of t. Okay, let me see what happened. I want to test if my equation are right. I'm going to put x equal to t equal to 0 here. My x become 1. And when I put t equal to 0, my y is 2. Let me see if it works. When t is 0, x is 1. When t is 0, y is 2. Therefore, if I put x equal to 1 here, I should get 2. When I plug 1 in here, that becomes a negative 1, and negative plus 1 cancel out, and that becomes 2 times 1, 2. My equation is right. Then I'm going to take this pair of equation, and I'm going to graph it. And I'm going to say the graph of this one, this is my x-axis, and this is my y-axis. When t is 0, remember we're going to have 3 vertical bar. One is for the t, one is for the x, one is the y. But the graphing calculator graph is a pair of, is a set of order pair. When the t is 0, your x is 1, and your y is 2. When the t is 1, the x is 3, and negative 4 plus 2 is negative 2. When t is 2, that's the 5, and that's become a 4, negative 20 become a negative 18. What happens if it's a negative 1? It becomes negative 2 plus 1 is a negative 1, and if it's a negative 1, it becomes a positive 1, and that become a negative 2. Okay, therefore I'm going to go graph that one and then say negative 1 and negative 2, 1 and a 2, 3 and a negative 2, and 5 and 18. Therefore, I see my graph is going to be right here, and that's my orientation, and that orientation give you for the t equal to, I put 2 and a 5, I put 2 here, I didn't do right. I had 1 and a 2, 3 and a 2, 1 and a 2, and 3 and negative 2. Okay, we good. Okay, that's my path. Right now you're going to say, okay, sir, if this is your path, what is the velocity at that point? What is the velocity at that point? What is the velocity at that point? The velocity is a tangent line to the path. And if I graph a set of all this velocity at t equal to 1, 2, 3, 4, 5, find the velocity and graph it, then you're going to have another path. They're going to have another path. I'm not going to tell you what that path looks like, but I'm going to assume the path is going to become like this. Therefore, you're going to say, what is my acceleration? Is my acceleration is all positive? Is my acceleration all negative? Then you're going to talk about the second derivative. Then let's talk about derivative here. Derivative is going to tell you the slope of a tangent line and many other applications. Or if you want to write the equation of a tangent line at that point. Therefore, for t equal to 1, I want to know what is dy dx, the slope of a tangent line. But please remember, when you do plane curve, you do it on xy axis. T right here is pretty much like a detective. It works behind the scene, but nobody see the detective after you graph it. Therefore, the path is there. I don't see the detective. I only see x and a y. Therefore, whenever you want to take the derivative, you only have to apply dy dx because that is your derivative. You have to write as a function of x. But my y is a function of t. My x is a function of y. How am I going to pull a dy dx out of it? Well, if you write dy here and a dx here, I can do this one respect to the t and put a dt right here and apply the chain rules. And when these cancel out, that becomes the derivative. But somebody said, where did this come from? I said, that's the multiplication. Multiplication can be changed to division because you multiply by reciprocal. Therefore, the reciprocal of it is here. The reciprocal of that one is here. And the top is here. And I see what is left is dy dx. Then from today, you have to know the derivative of a parametric equation is the derivative of y respect to t over dx dt. Therefore, when you take the derivative, whatever you want to do with parametric equation, that detective is going to appear and start working on it. And first, the minute you do the derivative respect to the t, again, the detective is going to disappear. Okay, what is the derivative of y respect to t? Is negative 8t. And what is the derivative of x respect to t? Is 2. Therefore, that gives you the slope of the tangent line and the slope of a tangent line to the plane curve. At any t value, okay, in here when the t was negative 1, your x is negative 1 and negative 2. And if I make my t negative 1 here, my slope of a tangent line at that point is negative 4. Means you have a falling line here. But if I put something like dy dx, what is it when the t is equal to, for example, 2? Okay? What is negative 8 times 2? Is negative 16 divided by 2 is a negative 8. I bet you I made a mistake right here because this one was a rising line. How did I come up with a negative right here? Remember in here I said t equal to negative 1. And what is negative times a negative is a positive. And as a positive, it becomes a plus 4. I just quickly saw that that's a rising line. Here is a falling line. But somebody said, oh, okay, when the t is 0, your derivative is 0. And when the derivative is 0, you have a turning point. I don't know if the turning point is max or a mean. Therefore, when the t is 0, your derivative is 0. Oh, when the t is 0 is 1 and 2. Oh, where is 1 and 2? Is your vertex. And the slope is 0. And this is the point of 1 and 2. What is the equation of a tangent line? Is a horizontal line, y equal to 2. Because your slope is 0. And when a slope is 0, make the whole thing 0, and is y minus a 2 equal to 0, y equal 2. Therefore, you know I can use the first derivative to be able to find the slope of a tangent line. Okay, let's make it a little bit more complicated function. I have x of t equal to natural log of t, 2 natural log of t plus a 5, and y of t equal to square root of t plus 2t. And somebody said, what is dy dx? Number 1, first you have to determine what number you cannot assign to these t value. Natural log of t, natural log is the inverse of exponential function, and the value of a t must be greater than 0. It cannot become equal to 0. Therefore, this has to be greater than 0. This one, t can be greater than equal to 0. Therefore, if this one is t greater than 0, and this one t is greater than or equal to 0, where they overlap, you cannot include the 0. Therefore, t must become greater than 0. Well, what is dy dx? dy dx is gonna be a function of t again, because I need dy dt on the top and dx dt on the bottom. But remember, because parametric equation, we always write the y second, but the derivative dy dt come on the top. Students have an intention of putting dx dt on the top. No, this one right here. And what is the derivative of t to the power of 1/2 is negative 2 over a square root of t plus a 2. What is the derivative of a natural log? 1 over a t. Therefore, that answer is going to become, I'm going to take the common denominator, it becomes negative 2 plus 2 square root of t times t, because I multiply by reciprocal, divided by 2 square root of t. T has to be a number greater than 0, maybe 4. If t becomes 4, tell me what is dy dx when the t is 4. The square root of 4 is 2. 2 times 2 is 4. 4 minus 2 is 2. 2 times 4 is 8. The square root of 4 is 2. 2 times 2 is 4. The slope of a tangent line is 2. Then somebody gonna say, okay, what is my second derivative? Is the derivative of the first derivative, which this one is d squared y over dx squared. Okay. Remember, when we take the first derivative, we selected this pair of equation. But when we're taking the second derivative, what it comes sit in place of my y is your first derivative. Because you're going to take the second derivative, and first derivative comes in place of y. And what is your second derivative? Your second derivative is here. But I'm going to put it right here because it's easier to differentiate that one than that one. It becomes negative 2 over a square root of t plus a 2 over 2 over a t. And what is your x? My dx dt gonna repeat itself. Therefore, the second derivative is the same as the first derivative, except in place of the y, you're going to see dy dt sitting right here. And somebody said, how do you take the second derivative, which is d squared y over dx squared? I need the derivative of the dy dx, that's the dy dx, on the top. That's your y. Well, I have to apply the quotient rules. What is the derivative at top? This one is negative 2 t to the power of negative 1/2. Therefore, it becomes negative times negative is a positive, 2 times 1/2 is a 1, t to the power of negative 3/2 times the bottom minus bottom is 2t to the power of a negative 1 is negative 2t to the power of negative 2 times the top over bottom square. That's only the derivative of that divided by the same thing you had in the bottom of the first derivative. The bottom of first derivative is a 2 natural log of t plus 5, and it's going to become 2 over a t. Therefore, no matter if you take derivative 20 times, dx dt is going to be in the bottom. Right now, for the third derivative, you need a pair of parametric equation. Your y is your second derivative, but your x is going to be exactly the same thing you started with, because x was a function that arbitrarily we picked. Then we substitute in the Cartesian to get the y. Okay, but let me tell you something a little bit about the difference of the first derivative and the second derivative, and the first derivative of the parametric function, and also the parametric equations and the functions. Remember, whenever you had y equal to f of x, in order for that graph to represent a function, it must pass as a vertical line test. Vertical line test, that for every x value you have only and only one tangent line. Okay, I'm going to say I have x equal to 2t minus pi sine of t. And I'm going to have y equal to 2 minus pi cosine of t. I want to give my plane curve. When the t is 0, x is 0. But when the t is 0, cosine of t, when the t is 0, cosine of t, cosine of 0, I'm sorry, let me put it right here, I don't forget. When the t is 0, x is 0. But when this one is 0, cosine of 0 is 1. Therefore, your y is become 2 minus a pi. What happens if the t become pi over 6? When this become pi over 6, that's become 1/2. That become 2 pi over 6. Minus 1/2 pi over 2. Therefore, this becomes pi over 3 minus a pi over 2. That's 60 degrees minus 90 degrees is negative pi over 6. But when I put pi over 6 right here, that becomes radical 3 over 2 times pi. And 2 minus that one. That becomes 2 minus the square root of 3 over 2 pi. Therefore, this, I can graph my path for those 2 points. My x is 0. 2 minus a 3.14 is negative something. I have something right here. Negative power 6 is in here, but this one is 3.14. That's radical 3 over 2. I need a calculator, but I think this is a negative numbers. And if I take that one, is 2 minus, open parentheses, square root of 3. 2 minus the square root of 3 over a 2 over a 2 times pi, and that gives me negative 0.7. Therefore, when it's negative power 6, which is right here, I have something like that. Therefore, my graph is coming right here. Okay, then I'm going to plus right here, and I'm going to have a power 2 right here. Sine of power 2 is 1. That becomes 2 pi over 2 minus a pi. That make it a 0. Therefore, that's the 0. And when I put power 2 right here, make it a 0, and that's the 2. Therefore, my graph is going to go through here right now. Okay. Then I'm going to ask, it's going to go up in that path. But I'm going to pick a pi right here someplace. Let me put a negative power 2 right here. Sine of negative power 2 is negative 1. Negative times negative is positive. Therefore, it becomes pi times sine of power 2 is 1, negative 1. That's a pi. And when I put power 2 right here, that becomes 2 times power 2. That becomes 2 pi. Therefore, when I put 2 is here, it becomes a 2 pi. And 2 pi is something like here. And when I put power 2 right here, I get a 2. Oh. Therefore, somehow this graph is going to go in that direction right there. Okay. I want to know, at that point, you have a point of intersection. And I want to make sure my graph is correct. You go right here into parametric function, and you're going to type in 2t minus pi sine of t. I don't know why I put them on the y value right here, the x value, 2t minus a pi sine of t, and this one is going to become 2 minus a pi cosine of t. And when I go to my window, I go from 0 to 2 pi. Let me see what my graph. Okay, see, I got that graph right here, but I need a graph of a negative part right here. I go right here and I press my window in negative 2 pi, and I'm going to graph it. That's for that. Okay, that's not bad. That's my graph. Therefore, you know, at the point of 0 and 2, oh, you have a tangent line which is falling and a tangent line which is rising. And where did I get to? At pi over 2. Oh, that's good. Therefore, for this one, because it's counterclockwise, is power 2. For negative power 2, come back. For negative power 2, your R is 2, and that's what it is. Okay, that's not bad. Therefore, here I'm going to take the derivative, and I'm going to say what is dy dt. That's 0. The derivative of a cosine of t is negative sine. Negative times negative is a positive sine of t. Dx dt is 2. Derivative of a sine is a cosine. That's the cosine of t. Okay. Then, remember at the point of intersection, at that point of intersection, which t was power 2. Let me see, what is my derivative at t equal to power 2? Sine of power 2 is 1, you get pi. Cosine of power 2 is 0, you get 2. What happens if I put dy dt at the t equal to negative power 2? Sine of negative power 2 is negative 1. Cosine of negative power 2 is 0. You have that one. Therefore, remember, at that point, which I bet you I made a mistake right here. Negative power 2, sine of negative power 2 right here is 2 times negative power 2 minus a pi. Sine of negative power 2 is negative 1. Therefore, see, that 2 is cancelled, and that becomes a 0. That's where my mistake was. Okay. Therefore, for 2 points, you have sets of order pair. Therefore, in here, I have equation of 2 lines. Then remember, in parametric, not like a Cartesian, always at one specific point, you do not have one tangent line. It is possible to have 2. Therefore, this is y minus a 2 equal to mx minus a x1. That's for the rising line right here. And for the falling line, it becomes negative power 2 times x minus a 0. Therefore, this is for the falling line right here. Therefore, this one, unlike the Cartesian, at one point, you maybe have more than one tangent line. And there are other cases that I'm going to ask you if you have x of t equal to t, 2t plus a 1, and you have y of t equal to negative 2t squared plus a t minus a 1, I know I'm going to have a path. But I want to know about this concavity. When the graph is concave up, when the graph is concave down. I know for my derivative on a dy dt, and that becomes nothing except negative 2t plus 1/2. Therefore, in here, when the t, give me a number, negative 2t plus 1/2 is equal to 0, negative 2t equal to negative 1/2, and when I divided it by negative 2, t is equal to 1/4. If I pick 1/4 here, negative 2 times 1/4 is negative 1/2 plus 1/2, that becomes your critical point. But if you pick any number greater than this and any number less than that, like 0, positive, negative 1, positive, negative 2, positive. Therefore, when the t is less than 1/4, your function is going to increase, going up. But if your t become 1, negative, 2, negative, and after t become greater than 1/4, your function is decreases. But somebody said, with 1t, the graph is going to be concave down. You need the second derivative, because on the second derivative right now, your first derivative is your function, which is right here. What is your derivative? Negative 2. Then I need dx dt on the bottom, which is 2. You better say that's a negative 1, and that's always negative. Therefore, in no matter what t is, your graph is going to be concave down. You do not have any critical point like that one. Therefore, the graph is always going to be concave down. You do not have a critical point that you find that at that point the second derivative is 0. That's called point of inflection. That in here to the left is concave down and in here to be concave up. Therefore, if some number make your second derivative, that's my second derivative. My second derivative equal to 0, then you can say, put a test point when it's concave down, when it's concave up. At least we try to apply the parametric derivative into a parametric equations. And next video, I thought this is going to be last. I'm going to do the integration and maybe arc length and things like that.